Hello and Namaste. In continuation with the double integrals, we are going ahead with the change of order of integration, and we are dealing here with the part 1 wherein we are introducing with the detail about what exactly is the change of order of integration with the help of one very important example. Now the change of order of integration means on changing the order of integration, the limits of the integration change. The limits of the integration change. Second, to find the new limits, we need to draw a rough sketch of the region of integration. So the problem connected with the double integrals, which seem to be a little complicated, can be made easy to handle by change of order of integration. So this is an application of the change of order of integration. If one of the integration or the limits of the integration is a little difficult, we can go ahead, change the order of integration, we can solve, we will get the same answer as that of the original question. Okay, let us explore this with the help of example. Change the order of integration from 0 to infinity, integration from x to infinity, f of x comma y, dx dy. As soon as we could see this type of example and the question is change the order of integration, we have to first identify which all variables are given. So in this particular example, we have been given the variables as x and y. As soon as we have decided that okay, this x and y, these are the two variables have been given, we have to look at the inner integral or the integration which is there inside this the integration. So that we have to check it. Now in this case, the integration is depending on the variable x to infinity. That means exactly the variable y is missing out of x and y. So therefore this inner integral will be for y. So this is y is equals to x to infinity. Then we have to move to the outer integral, or you can say the second integral, which is now if we have decided that okay, this is for y, so obviously the outer integral is for x. So we have decided that this has been given to us as x and y. Now as soon as we have identified these variables, we have to first identify all these four integrals. So we have got these four integrals. Y is equals to x, y is equals to infinity, x is equals to 0 and x is equals to infinity. So we have to identify all these four different curves. Let us start with this. Now this is y is equals to x, means the line passing through the origin. So this y equals to x is the line which is passing through the origin. Second, y is equals to infinity, which are the points of y tending to positive infinity. So these are nothing but the points of y tending to positive infinity. Third one is x is equals to 0. Now x is equals to 0 is nothing but the equation of y axis. The fourth curve is x is equals to infinity, which is the points of x tending to the positive infinity. So the positive infinity, which is x. Now if you observe here, and we will just plot or do this particular curve, before going ahead we need to identify which all are the points of intersection of all these four curves. Now we have got here two curves, y is equals to x and x is equals to 0, which we need to consider the intersection point as. So y is equals to x and x is equals to 0. If you observe here, if you put x is equals to 0 in this equation, we'll be getting the value of y is equals to 0. This gives us x is equals to 0 and y is equals to 0. That means 0 comma 0, that is the origin, is the only one point of intersection of these two curves. And therefore if you observe, we can draw this type of curve like this. And if you observe here, now this is the inner integral is given to us for y. So if it has been given to us for y, we have to consider a strip parallel to y axis and identify the region over here. Now in this case, if you observe here, the outer integral is for x is equals to 0 to infinity, means x is equals to 0 is this y axis and infinity is is another line which is lying at the infinity. So we can easily check that the region is bounded between x is equals to 0 and x is equals to infinity. So x is equals to infinity is lying somewhere here, which is at the infinity. So this in short, we can understand that the region is lying between somewhere in the first or the fourth quadrant, not in the second or the third quadrant. Again, if you observe this, the inner limit again, this inner limit, the lower limit is lying on the line y is equals to x. So therefore this particular strip, which is the parallel to a y-axis, we need to understand the lower end of this particular line or particular strip is lying on y is equals to x line, which is this line. And the upper end is at y is equals to infinity. So y equals to infinity is like this, it will go on and on. So it will be towards the positive y axis. So towards the positive, so this is what is the another end. Just to show this particular curve, I have restricted myself so to a smaller extent, but this region would be go on doing it. So this arrows will tell you this particular region will be on towards the positive y-axis, and it is all the points which are above y is equals to x line. Again, this y is equals to x is an infinite line. Similarly, this y positive is again an infinite point. So we can have this particular region of this given region has been given to us as this. Now what exactly means the change of order of integration means? We have to make this strip which is given to us as the vertical first, we have to make it horizontal. In short, we have to bring it here, instead of this y, we have to bring it up here x. So limit of x, and this has to be limit of y. That means we have to change the order of integration by making the strip which is given to us as horizontal. We have to make it this strip as a given to us as a vertical, we have to make it as a horizontal. Let us go ahead and explore that. So change the order of integration, that is to integrate first with respect to x and then with respect to y. So we need to draw a horizontal strip AB parallel to the x-axis which starts from the line. So you can check it here. This is what we have to do it. So beforehand, or in the previous case, we had the strip like this, or a strip parallel to y-axis. Now we have to make a strip horizontal. Now whenever we are making a strip horizontal, we have to take care of this region. So otherwise you can say that this region, if you wanted to paint it, we have to paint it in this way. And therefore this end has to be on the line x is equals to 0, and the another end, or the B, is lying on y is equals to x. So if you'll observe here, in this case, the limits of x is equals to 0. So this is, if you'll observe here, the limit of x is from 0 to y is equals to x. Sorry, x is equals to y, because it's a x is equals to y, it doesn't matter, but still it is moving from x is equals to 0 to x is equals to y, and the limit of y is moving from, so if you'll observe here, it's 0 comma 0 till this particular y is moving till infinity. So y is moving or tending to the infinity, and therefore this y is moving towards the infinity, and this is what we have to understand, the change of order of integration. And therefore if you'll observe here, this was the limit given to us previously, or the original question, y is equals to x to y is equals to infinity, x is equals to 0 to x is equals to infinity. It has been changed the order to x is equals to 0 to x is equals to y, and y is equals to 0 to y is equals to infinity. If you'll observe here, we have not just simply written this and this interchange the limit. We have not interchanged the limit. Understand that we have taken the strip which was given to us as vertical first, we have made that strip as horizontal, and this is what we have to understand. This is what is known as the change of order of integration. And in short, if you'll observe here, in short, we have to understand the change of order of integration steps needs to follow. Let us say, check this as the example. We have to first identify the variables in the integration. So we have got y and x, these are the two integration variables. Second, the innermost integral is for the variable which is missing in the integral. So if you'll observe here, the innermost integral is given to us from 0 to y. That means x is missing over here. That means this inner integral is for x. So it is x is equals to 0 to x is equals to y. Similarly, the rest of the variables, so if we have got x and y, out of that x is, the inner integral is for x. So outer will be for y. So y is equals to 0 to y equals to 1. Third one is identify all four curves, that is x is equals to 0, x is equals to y, y is equals to 0, y is equals to 1, and the lower limits of both the integrals. Then find the point of intersection of all the curves. Draw all the curves with respect to the point of intersection. Identify the region of integration using the concept of a strip, whether it would be a horizontal or a vertical. Now in this case, this particular case, we have been given the strip parallel to x-axis because the inner integral is for x. Therefore the strip, we have to identify the region using the strip horizontal, or you can say strip parallel to x-axis, according to the step in the step 2. To change the order of integration, consider the opposite strip of the step 6. So if in this particular example we have been given, this is the given strip, so we have to make the vertical strip to change the order, of integration, and hence Write the limits of region of integration according to the strip, horizontal or vertical. This is what, and we know that how to do that. This is a horizontal strip. You have to take the left and the right end, and whenever you are considering a strip parallel to y-axis, we have to take the lower and the upper end on the curve, and then the movement of this x-axis, and here the movement of the y-axis from down to up, and here we have to take the moment of x-axis from left to right. This is what we have to understand to change the order of integration. I think you have understood it very well. Please stay tuned, stay connected for upcoming different questions based on the change of order of integration. Thank you. Happy learning.